Yeah, first of all, thank you for attending our third panel discussion at a conference. My name is Jürgen Oerlich. I'm the general manager of IoT systems. On the left-hand side here is Dr. Mohammed Islam from Princess Margaret Hospital in Toronto. On my right-hand side is Dr. David Jeffrey, also from Princess Margaret Hospital at Toronto. And we got together today, just like on the other occasions, to talk a little bit about what made them create the IQM, what are the problems that we're trying to solve with the IQM, what are the special features about the IQM, and where this whole IQM project is going to go from here. And I've prepared some questions, and the questions are here on my phone. I'm not reading emails. I'm only reading questions. You know the questions. All right. So the first question that I've prepared for this session here is, what made you come up with the idea for the IQM, and what kind of clinical problem did you try to solve when you came up with this idea? Thank you, Jürgen. Yeah, the idea of this IQM system, I think, started back in year 2000 when we first started implementing our IMRT in the clinic. At the outset, we identified two challenges and maybe two opportunities also. One of the challenges was, as you all know, when you implement an IMRT program, that you started with doing lots of measurements, especially for patients' retreatment quality assurance measurement. So you do lots of ion chamber type measurement with different type of detectors and film measurements and all that. And you put lots of time and effort, but finally when you validate these results, a lot of times that you have to hand wave and just to think, well, how to justify whether this plan is accurate for treatment. So this is kind of challenge that we noticed. On the top of that, then, what we noticed that as you do that and start treating the patient, subsequently you worry about whether the machine is performing the right way. As you know that if you have only 1 millimeter error in MLC lead positioning, you may be, for a small segment, you can be delivering a wrong dose by up to about 10% or so. So that, in addition to that on the background, there are, machine can have a breakdown, and there may be a repair going on, there may be software upgrade going on. So subsequently, you don't know whether the patient is receiving the right dose during the entire course of treatment. So we thought that what if we can create a detector which can be put on the collimator, and that can allow monitoring each treatment fraction automatically without much user intervention, and also that the type of detector that we would make, which would provide a simple figure of merit as opposed to a complex dose volume histogram or some kind of analysis and all that. So with that idea, we started looking at a dose area product meter, which is readily available at that time, of course now also for diagnostic radiology. So with the dose area product meter, we started doing some initial measurement, and we proved the concept. Subsequently, we thought that we need to be able to predict what the signal should be for each IMRT field. So then we started looking at the modeling of the chamber in terms of its sensitivity. So we noticed the sensitivity across the chamber was not uniform. So it did have a non-uniformity. So we were at that time thinking what to do about that, because we imagined that we'll have a uniform sensitivity. At that time, I think we were having a brainstorming session with Dr. Jeffrey's office that, what to do about it. So then, of course, with his ingenious thinking, he just thought, why should we fight the non-uniformity? But maybe we should introduce some kind of intelligent non-uniformity on purpose. So that led to the development of, a gradient, a simple gradient ion chamber, and that led to this IQM development subsequently. You want to add something?
Yeah, no, I think this is, Mohammed's covered it very nicely. It started from clinical need, and we do all this work to commission these machines and get them going. But we do know that it's a collection of technologies that are going through upgrades and changes, and the same kind of thinking. We'd like to have something that allowed us to make sure the system was stable and consistent over time. And the world around us right now is full of low-cost measurement. You have Fitbits and all kinds of things, and this is the exact same trend just coming into this field, where we're making measurements at a very low cost, at a very high frequency, and we can provide an assurance. The way I like to think of it is it really provides this layer, sort of this layer between the patient and the machine. And it's not the vendors. It's something for us to use to watch to make sure everything is stable. I know, for example, when we do one of our upgrades for the R&D system, for example, we do a bunch of tests to make sure what was transferred to the machine was the same before. And then using this kind of a tool to verify that that's all working exactly the same in the random selection of cases is another example of that additional shield that is possible by having these measurements, which started out of just traditional MRT QA, but we realized it's so easy to make the measurements and to just integrate it into this layer that I think it'll change a lot more of our practice too.
I think that's a very important point, is the integration capability of the IQM. That it will be a game changer on the verification side, with the frequency and the integration into the overall treatment planning and delivery process. We installed the first IQM, I think, at Princess Margaret Hospital of this new type, of the type that IRT actually developed about 1.5 years ago. 1.5 years ago. So my question, what is your experience with the IQM regarding user-friendliness, accuracy of results, etc., that you have experienced in the last 1.5 years? Can you expand a little bit about this?
Yeah, I think since we entered this collaboration, we have the IQM chamber now wireless with the Bluetooth technology. It has become so easy now for us to test. I mean, we don't have to run cables through the bunker holes and all that. So it's easy now that we put it in, and we get wireless connection, and we get measurements done based upon whatever test we want to do. So it allows us to do tests much more easily, more reliably. So far what we have seen in terms of its reproducibility and then the stability is quite remarkable. So and then the software integration that has been made by PMH and IRT collaboration is helping us to do all those tests.
So based on this experience, do you expect to start using the IQM at some point, obviously after we have fulfilled all of our regulatory requirements in Canada, that you're going to use this device clinically in your routine? Is this a plan?
Yeah, I mean, this is, we're very much in driving to lowering the cost of maintaining very high quality radiotherapy. And so, well, at the beginning we're sort of thinking about IMRT commissioning, and then VMAT commissioning is also very nice, and then monitoring for patient-specific QA is quite attractive. But then if it's in there all the time, it lets us make measurements all day long at all gantry angles, and we have 16 accelerators. So I just want to make sure that they're all working as they're supposed to be. So that wire that comes off this thing just can feed that from multiple centers. And so our vision is not just to address a problem we had. Our vision is to make our quality be much higher, or as high as it is now, but at a much lower cost. So I want to be able to start looking at taking out morning checks, integrating looking at monthly to be looked at again, completely from the perspective of we need to make these measurements on these intervals when I'm getting the data coming in over time for every patient, for every machine. So, I mean, this is the structure, I think. And you could say, should it be built into the machine? Well, like I said before, I like this as the SCART approach that works for all the machines and all the patients. That's where we like to go.
That sounds extremely exciting, and we are really looking forward to be part of this. One thing that we're going to hear on Tuesday from one of your colleagues is a presentation about using an IQM for stereotactic body radiation therapy. And I know therapy that is quite heavily used at Princess Margaret Hospital. And so why my question would be there is, why do you think that IQM is especially useful for those high dose, low number of fractions or few number of fraction, small fields kind of treatments?
Yeah, it's an easy one. Okay. You're going to think I already answered that question. So, I mean, these treatments are few in number. Any error on any fraction is a substantial dose deviation. There are other groups who are going to single fraction radiotherapy, and in this context, and of course, you have to have great confidence in the execution of the machine, and this would provide us with that. One of the things that we had to do actually with this was because of the enormous amount of charge that's produced in that chamber for a very large total charge generation for like an SBRT case, they had to make a dedicated new electrometer system in there to do that. But I mean, it can support very high dose rates, and of course total charges is not an issue for tapping it off. But I think one of the next things that we're realizing is there's an interest in doing some adaptive work, and those kinds of changes that will come through time are going to really stress the QA architecture. And so the potential for us to use this to do online corrections, we'll see that's kind of a little more aggressive, but even adaptive changes over the course of radiotherapy without doubling up on the patient-specific QA, I think is quite attractive. So SBRT is one side, but I think the adaptive story and being sure that the change you requested actually got to the machine, and having that verified by the dose that's going out and recorded by the signal from the IQM, I think really creates a very tight interlock now for changes.
Okay. I mean, one of the questions that obviously gets asked quite often when you talk about this kind of transition detector is how do you make sure that you know what gets out of the machine, but how do you make sure that it gets delivered correctly to the patient? I mean, that's one of the questions when you do the exit dosimetry versus transient dosimetry. Is there anything
it is true that we cannot directly verify the patient received the dose, but it's a standard practice in radiation therapy that the patient will be positioned, and position will be verified through cone beam CT or similar technology. After that, beam is delivered. So with that integrated loop, I think we can be certain that the patient is receiving the right dose. I think that's our position right now.
And so this means that we have two independent systems, one that monitors the dose that comes out of the linear accelerator, and then a different system that actually makes sure so the patient is at the place where it should be, and then the tumor is especially at the place where it should be. All right. And another question is, I mean, these two gentlemen here are medical physicists, and we are looking at the IQM also a lot from the medical physics point of view, but from your point of view, what would be the advantages for radiation therapists or even for the radiation oncologists of using the IQM?
Well, I think the therapist, the oncologist, of course, would recognize the fact that you have another layer of safety, sort of a continuous checksum of the plan's integrity right before you treat the patient. And if this is interlocked to the machine directly, then that's very powerful. I think that's just really like an airbag kind of thinking. You have a picture of an airbag here somewhere. And that approach, I think, is quite attractive. I mean, we have this initiative in our hospital called the High Reliability Organization, so-called HRO, where we talk about 0 and 100%. 100% of the time, nothing goes wrong. And this is versus the sort of tales of probability that we allow sneak through, but there are healthcare organizations now who are expecting no catastrophic events in their organization. It's not like we like to get it to 5-9, so they're talking about 0. And so how can we get to 0? And so this kind of device in my mind is about getting to 0. It's not about process, it's not about training, it's about it just can't get there. It's a shield of sorts. So from an oncologist's point of view, you can kind of understand the strength of that argument. What I also found is that the therapists now, in my interactions with them, we've done some human factors work in this area, the machines are incredibly complicated. You can look at the leaves moving around and the MUs ticking and the here and there, but there's not really anything that's kind of saying, is it progressing along as it's supposed to? Is the machines, the quantity that's actually getting to the patient, making sense from what the plan is? And I think there's an opportunity to present this measurement through time in a way that they really have a direct link to a very relevant quantity to assure them that machine is delivering inside a tolerance window of what has been pre-calculated. Because they can't watch all the views, they can't watch all the signals, and they don't make any sense, and so you're actually distracting them. So this gives them a very clean signal to watch, and while they're also watching the patient for obvious care and care reasons. So I think it's really interesting how it has many different dimensions.
Yes, continuing on David's last point, recently we recruited a bunch of volunteer therapists to play with the IQM system, and they made a great, the comment about this, watching this dose delivery tunnel, that it is showing the signal approaching through the predefined tolerance tunnel. So, I mean, all the therapists are excited about that they will know now the delivery is progressing correctly. Okay.
No, I think that, from my point of view, that all sounds extremely promising. I think this 100% and zero errors is something that we are looking forward to, and let us know as soon as it and if nobody else has any questions, I would like to say thank you for your attention, and tomorrow at 11:45 this gentleman Martin is going to give us another presentation, so please come back here tomorrow at 11:45. It's definitely worth it, and thank you very much for your attention. Thank you very much, David, for coming. Thank you very much, Mohammed, for coming. Thank you.